Hi, I'm an old guy and I do maths. And what we're looking at is a problem that a middle school, high school student of mine had some trouble with. Now, she's just starting out in trigonometry, and so she knows about sines, cosines, and tangents and how they apply to right-angled triangles. She does not know anything about the sine rule or the cosine rule, which we might well avail ourselves of to solve this. So what we're going to do here is we're going to solve this using the knowledge that someone starting out in trigonometry would have, which is really just about right-angled triangles and sines, cosines, and tangents. So how do we go about this? Well, the first thing that I would do in such circumstances is I'd figure out the height of this triangle here. I'd find this length here. And what that's going to allow us to do is to find a whole pile of other things. Okay, so let's take the right-hand side of the triangle and redraw it here. So that's our Z. We'll not worry about this just for the moment. We'll deal with Y in a little bit, and we can also deal with X separately. That's not a major problem. So we have a measurement of 75 units here. I can't remember what the exact unit was, so we'll just call it units. And this angle here is 49 degrees. So what do we know? Well, this is what she had to work with. And so we have an opposite side here and a hypotenuse. Opposite and hypotenuse, so the sine of 49 degrees is equal to opposite over hypotenuse Z over 75. Now, she's in the position where she can just pop that into a calculator and that will solve it. So I'm not quite in that position. So 75 times the sine of 49 degrees is going to equal our height, Z. So let's find that. 75 times the sine of 49 degrees is 56.60 and some considerable change. So I'm going to note this here in red in full, 56.60321852. Now, if I were being lazy, I would round this to 56.60 and continue on my merry way. But I'm going to do this properly. I think the instruction she had was to round it to 2 decimal places for the solution for x and y. In order to make sure that they're accurate, we need to leave this with as many decimals as we can get. Okay, so now we know the height of this thing. So what I'm going to do now is draw 2 more triangles that constitute the totality of the original triangle. And between these, I'm going to write the height, 56.60321852. Now that applies here and here. We have 49 degrees here. We have 75 there. We have 32 degrees here, and we're looking for something there. And I haven't forgotten that we're looking for the totality of this measurement here. We'll come to that. Okay, so let's deal with this now. So what we have is we have an adjacent side and a hypotenuse. So that takes us to the cosine. So I'll just find some room here on my somewhat crowded desk. So the cosine of 32 degrees is equal to 56.60 and some change over x. So this over this, adjacent over hypotenuse. Now, rewriting that, all I do is swap the x and the cosine. So x is equal to 56.60 and all the decimals over the cosine of 32 degrees. Now, I hope you can see that. I'm going to divide the full number by the cosine of 32 degrees, and I'm going to get that, 66.745, etc. So x is equal to, I'll leave that down there, so is that visible to you? I just need to get that into the light for you. There you are. X is equal to 66.74529,284 units. We don't know what they are. Now, we're in possession of everything we need to find y. We can find this length and we can find this length. Call them y1 and y2 if you will, but we can do that. So how do we go about that? Well, we have a choice. We can use trigonometry. We can also use Pythagoras because this length squared minus this length squared will give us this length squared. This length squared minus this length squared will give us this length squared. And that would be my preferred method because it takes you out of the realms of trigonometry and it's generally a little bit faster. However, I'll do this using trigonometry. So what we're looking for, we'll call this y2 and we'll call this y1, and we'll combine them in a minute. So finding y2, we're looking for this length, we have this length. So we have the adjacent and we have the hypotenuse. So the cosine of 49 degrees is equal to the adjacent, y2, over 75. So 75 times the cosine of 49 degrees is equal to y2. Right, let's find that. So 75 times the cosine of 49 degrees. That is equal to 49.20442717. Again, there you are. Now, I'm going to do a very rough check on that. I'm going to square 75, and from that I am going to subtract 56 squared. Very, very rough calculation. I get that, and then I'm going to find the square root of that. And the answer is 49 and some change. So that's all to the good. That's a satisfactory answer. Now, this one. y1, which is this, is the opposite of the angle here. So we are looking for a sine of 32 degrees is equal to y1 over x, which we know to be 66.7452984. So that number, let me get this in frame, that number times that will give us that. Let's go. 66.7452984 times the sine of 32 degrees, which gives us that, 35 and some change. So that is 35.36961942. Now, I'm going to check that as well, because I know roughly what this is. We'll call this 67. I know roughly what this is. We'll call it 56. And I'll see when I do a bit of Pythagoras, this squared minus this squared, see if it equals the square of this. So, very quickly, 67 squared minus, what is the number I'm looking for? 56 squared equals 1353. Again, this is a very rough check calculation. Find the square root of that. 36, that's near enough for me. So, what does y equal? This thing that we started out looking for. We found x. We can now say that x is equal to 66.75. 2 decimal places. Y is equal to 49.20, I'll put that in frame so you can see it, 20442717 plus 35.36961942. And that gives me 84.57. I'm rounding to 2 decimal places. You can see that it'll be 84.57. And that is the answer, and that is one of the ways in which you can get it. As I said, you could use probably the sine or cosine rule. Haven't thought about it too hard to figure it out if you knew that. But we're working on a mid sort of high school knowledge of basic trigonometry to do this. Thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.